Inside the cramped hull of an M4 Sherman tank somewhere in Normandy, June 1944, Staff Sergeant Robert Hayes pressed the transmit button on his SCR-508 radio and spoke calmly into the microphone. Baker 2-3, enemy armor, 3 o'clock, hull down behind the hedgerow, approximately 400 yards. His voice, crystal clear despite the roar of the engine, reached 4 other tank commanders simultaneously. Within seconds, the American platoon was maneuvering, 2 Shermans moving to flank, 1 backing into cover, another radioing coordinates to a tank destroyer platoon 200 yards behind. The entire choreography took less than 30 seconds. 300 yards to the north, inside a Panzer IV, Unteroffizier Franz Becker saw the same enemy position. He couldn't radio anyone. His tank wasn't equipped with a transmitter, only a receiver for orders. He opened his hatch, exposing himself to machine gun fire, and began waving colored flags at his platoon leader's tank. The platoon commander, trying to read the signals through his periscope while under fire, couldn't make out the meaning. Becker climbed further out, shouting and pointing. By the time the message was understood, the American Shermans had already moved. The German response would be improvised, uncoordinated, based on what individual crews could see from their limited viewpoints. This scene, repeated thousands of times across North Africa, Italy, France, and Germany between 1942 and 1945, reveals a profound truth about armored warfare that even many historians have overlooked. German tank crews, climbing into their Tigers and Panthers, machines genuinely superior in armor and firepower, believed they were facing inferior American equipment operated by inexperienced crews. What they never realized was that they weren't fighting tanks. They were fighting a network. Every Sherman commander could talk to every other Sherman in his platoon, to his company commander, to supporting infantry, to artillery batteries miles away, to tank destroyers, to forward air controllers. The German tanks, technological marvels of steel and engineering, fought largely alone, guided by plans made before battle and unable to adapt quickly to changing circumstances. When American tankers spoke about their experiences decades later, they rarely claimed the Sherman was better than the Panther. They knew the brutal truth. In a one-on-one fight, the German tank would likely win. But armored warfare was never about one-on-one fights. It was about information, coordination, adaptation, and combined arms. The most powerful weapon in the Sherman wasn't its 75mm gun. It was its radio. And that radio, more than any other factor, explains why American armored forces achieved what the German General Staff thought impossible. They won a war of maneuver against an enemy with superior tanks. What armored warfare was supposed to be. The theorists who pioneered tank warfare in the 1920s and 1930s, J.F.C. Fuller, Basil Liddell Hart, Heinz Guderian, envisioned armored combat as a contest of mobility, shock, and concentrated firepower. Tanks would punch through enemy lines, disrupt rear areas, and paralyze opponents through speed and surprise. But when military planners translated theory into hardware, they defaulted to the oldest measure of military power: the ability to destroy enemy equipment in direct combat. This mindset dominated German tank development. Each new model prioritized thicker armor and more powerful guns. The Panzer III gave way to the Panzer IV, which was then supplemented by the Panther and Tiger, each generation designed to dominate the tank versus tank engagement. German crews trained extensively in gunnery, in reading terrain, in the tactics of the ambush and the armored duel. The Tiger I, introduced in 1942, embodied this philosophy perfectly: 88mm gun that could penetrate any Allied tank at ranges exceeding a mile, frontal armor thick enough to deflect most Allied anti-tank weapons, a reputation that preceded it and shook Allied morale. When American tankers first encountered Tigers in Tunisia, the results confirmed German assumptions. Shermans were knocked out at ranges where their own guns were ineffective. The 75mm M3 gun, adequate against Panzer IIIs and early Panzer IVs, simply could not penetrate a Tiger's frontal armor except at suicidally close ranges. After-action reports were grim. Crews reported that hitting a Tiger head-on was like bouncing marbles off a brick wall. The Sherman's armor, only 76mm at its thickest point on the front glacis, offered little protection against the Tiger's 88mm rounds, which could penetrate it from nearly any angle at combat ranges. The narrative seemed clear: Germany had built superior tanks, and American crews were paying for that inferiority with their lives. Newspapers back home ran stories about the Tommy Cooker, British slang for the Sherman, and questions were raised in Congress about American tank design. What neither the reporters nor the congressmen nor even many military analysts understood was that the Sherman had never been designed to win the kind of fight the Tiger was built for. The Sherman was designed to be part of a system, and systems operate according to different rules than individual weapons. The radio revolution inside the Sherman. Open the rear deck of an M4 Sherman and you'll find something remarkable for a 1942 vintage combat vehicle. A sophisticated FM radio system designated the SCR-508, occupying a protective compartment built specifically for it. This wasn't an afterthought or a luxury item installed on command vehicles. Every single Sherman that rolled off American production lines, whether from Chrysler's Detroit Arsenal, Ford's River Rouge plant, or the Pressed Steel Car Company, came equipped with a working radio capable of both transmitting and receiving on multiple preset frequencies. The SCR-508 operated at 25 watts transmission power using frequency modulation across the 20 to 27.9 MHz band. For readers unfamiliar with radio technology, those specifications translated into practical battlefield advantages. The 25-watt power output gave the radio an effective range of 3 to 5 miles under typical combat conditions, far enough to coordinate an entire armored battalion. The FM technology, revolutionary for military applications at the time, eliminated much of the static and interference that plagued older AM systems. A tank commander could speak in normal tones and be understood clearly by other commanders, even with engines running and guns firing. The radio featured 6 preset crystal-controlled channels. This meant a Sherman crew could instantly switch between frequencies without manual tuning: platoon net, company net, battalion net, artillery net, air support net, each accessible with a simple switch rotation. The company commander could monitor the battalion frequency while his crew listened to the platoon net, switching back and forth as needed. When contact was made with enemy armor, the company commander could instantly relay that information up to battalion while his platoon leaders coordinated their response on the lower frequency. Inside the turret, the tank commander wore a throat microphone and headset, leaving his hands free to command his crew and operate his weapons. The system was designed for simplicity. Training manuals emphasized that any crew member could operate the radio with minimal instruction. This wasn't communications equipment for specialists. It was basic equipment for tank operations, as fundamental as the main gun or the engine. American doctrine assumed radio communication. Tactical manuals described in detail how platoons would coordinate movement, how information about enemy positions would be shared, how supporting fires would be called. Tank crews trained not just to fight their individual vehicle but to fight as elements of a larger formation, using radio communications to achieve what individual tanks could not. The platoon leader wasn't just commanding his own tank. He was orchestrating 5 tanks acting in concert, seeing through 10 eyes instead of 2, bringing 5 guns to bear on problems in coordinated fashion. The radios were rugged, designed to withstand the vibration, dust, and shock of armored combat. They were also standardized. Every SCR-508 was identical, which meant spare parts were interchangeable, repair procedures were universal, and replacement radios could be installed quickly. When a Sherman threw a track or suffered engine trouble, recovery crews would often salvage the radio for installation in another vehicle. The radio was that valuable, that essential to operations. German radios. Rare, weak, and misunderstood. The German approach to tank communications reveals a fundamental difference in military philosophy. In German armored units, radios were installed based on hierarchy, not operational need. A typical German tank platoon in 1944 consisted of 5 tanks. One commanded by an officer, usually a lieutenant, for commanded by NCOs. Only the platoon leader's tank carried a transmitter, a 10-watt AM radio designated Fu-5. The remaining 4 tanks had only receivers, designated Fu-2, which could listen to orders but not send messages or coordinate with each other. This 10-watt AM system, even when working properly, had an effective range of only about 2 miles under ideal conditions. Combat conditions were never ideal. The AM technology meant heavy static from engine ignition systems, interference from other radios, and signal degradation in rough terrain. German tank commanders frequently reported that they could barely hear orders over the radio, and that metallic crashes, squeals, and interference made communication unreliable at critical moments. The statistics are stark. In 1944, roughly 20% of German tanks in any given formation had transmitting radios. This meant that in a company of 22 tanks, only 4 or 5 could send information to higher command or coordinate with supporting units. The other 17 tanks operated on doctrine, pre-battle orders, and visual signals. Flags, colored smoke, signal lamps, or simply opening the hatch and shouting. Why this limitation? The German General Staff had developed tank tactics in the 1930s based on the assumption that armored units would operate under detailed pre-planned operations, with clear objectives and careful coordination established before the battle began. Radios were for commanders to issue orders and for senior officers to monitor the battle's progress. Lower-level coordination would happen through training, doctrine, and the initiative of junior officers responding to the situation as they saw it. This worked brilliantly in Poland and France, where German armored spearheads, operating under favorable conditions against disorganized opponents, achieved stunning victories following carefully planned operations. But it began to fail in Russia, where vast distances, terrible weather, and Soviet resistance created chaotic, fluid battlefields where pre-planning couldn't account for rapidly changing circumstances. It failed even more dramatically against American and British forces, who had studied German tactics, prepared counters, and could adapt faster because every fighting vehicle could communicate. German tankers developed elaborate systems of hand and flag signals. Different colored flags indicated different messages: enemy armor, enemy infantry, change formation, halt, advance. Tank commanders would stand in their open hatches, exposed to enemy fire, waving flags or using signal lamps. In heavy terrain, forests, urban areas, anywhere that broke line of sight, these signals became useless. Units fragmented, individual tanks fought isolated engagements, and the coordination that Guderian's theories demanded evaporated under the friction of combat. Worse, the German system created bottlenecks. If a platoon spotted enemy positions, the information had to flow from observer to platoon leader, who would radio the company commander, who would radio the battalion commander, who would coordinate artillery response. At each level, precious seconds or minutes elapsed. Meanwhile, American platoons were calling artillery fire directly, sharing targeting information across the entire company front, adapting their movements based on information from tanks they couldn't even see. First contact, Kasserine Pass, 1943. The first major engagement between American and German armored forces in World War II took place in February 1943 in the barren hills of western Tunisia, at a gap in the mountains called Kasserine Pass. For the Americans, it was a disaster. Inexperienced units, poorly positioned, were routed by veteran German forces under Erwin Rommel. American tanks were destroyed, infantry units broke and ran, and the German advance pushed American forces back 50 miles in some sectors. But Kasserine Pass, despite being an American defeat, illustrated something that German commanders failed to appreciate: the American capacity to learn, adapt, and improve with extraordinary speed. What made that adaptation possible was communication. Even as American units retreated in disarray, battalion and company commanders were radioing detailed reports about German tactics, tank deployments, artillery concentrations, and the locations where American equipment was succeeding or failing. Within days, American doctrine began to change. Staff officers compiled after-action reports that included information from dozens of unit commanders, cross-referencing observations to build a comprehensive picture of what had gone wrong and what had worked. Tank commanders reported that German tanks could engage at longer ranges, that frontal attacks were suicidal, that flanking maneuvers and combined arms coordination were essential. Artillery observers reported German movement patterns. Intelligence officers triangulated German radio communications to map unit dispositions. This information flowed back through communication channels to training centers in the United States, where tactical doctrine was revised. Tank crews arriving in North Africa after Kasserine received updated training on German tanks, on combined arms tactics, on the importance of coordinating with tank destroyers and artillery. The American military, enabled by its communication infrastructure, was learning as a system, incorporating lessons from the front into training and doctrine faster than the Germans could exploit their initial advantages. By the time of the next major engagement at El Getter in March 1943, American tank units were fighting differently. They avoided head-on charges, instead using mobility and terrain to force German tanks into situations where American advantages in coordination and supporting fires could be brought to bear. When German armor attacked American defensive positions, they ran into interlocking fields of fire, with tank destroyers in hull-down positions, Shermans maneuvering on flanks, and artillery called down with precision based on radio reports from forward observers. The Germans won individual engagements, but they couldn't achieve the kind of breakthrough they'd accomplished in February. American units, even when pushed back, remained in communication with higher command. Retreats were organized, not routes. Reserves were committed where needed based on real-time information, not pre-battle planning. The American system was learning, adapting, improving, and it was doing so faster than German forces could adapt to changing circumstances. How radios changed the battlefield. Understanding the tactical impact of radio communications requires thinking about armored warfare differently than the tank versus tank duels emphasized in popular history. A Sherman platoon moving through French hedgerow country in July 1944 wasn't hunting for enemy tanks to fight one-on-one. It was acting as the eyes and ears of a larger organization, coordinating its movements with infantry, artillery, air support, and adjacent units to accomplish objectives while minimizing casualties. Consider a typical scenario. A Sherman platoon encounters resistance from a German strongpoint, anti-tank gun, machine gun nests, infantry in prepared positions. In a German formation, the platoon leader would assess the situation, decide on a course of action based on his training and his limited perspective from one tank, and lead his platoon in execution. If he made the wrong call, if there was a second anti-tank gun he couldn't see, if the position was stronger than it appeared, his tanks would pay the price. In an American formation, the sequence was different. The lead tank commander, spotting the resistance, would radio his platoon leader, "Contact, anti-tank gun and infantry. Approximately 300 yards, coordinates Baker 7-4. The platoon leader, from his position further back, would radio the company commander, Red 1 to Red 6, enemy strong point Baker 7-4, engaging. The company commander, monitoring multiple platoon nets, would have a broader picture. Were other platoons encountering resistance? Was this an isolated strong point or part of a larger defensive line? Within minutes, multiple assets would coordinate. The company commander would radio artillery, fire mission, coordinates Baker 7-4, suspected anti-tank gun and infantry in pillbox. Artillery forward observers would confirm the target and call for fire. The company commander might radio a tank destroyer platoon. White elements, move to support red platoon, coordinates Baker 7-4. He might radio adjacent infantry. Enemy position Baker 7-4, can you flank from the north? Meanwhile, the Sherman platoon wouldn't charge the position. They'd suppress it with machine gun fire, use smoke to obscure enemy observation, and wait for the coordinated response. When the artillery barrage lifted, when the tank destroyers were in position, when infantry had maneuvered to hit the flanks, the attack would proceed with overwhelming force concentrated at the decisive point. The Sherman platoon might never fire their main guns at the enemy position, the anti-tank gun might be destroyed by artillery, the infantry might surrender to the flanking force. What mattered was that the strong point was eliminated with minimum American casualties, and that happened because of coordination enabled by radio communication. This pattern repeated across every level of combat. Tank commanders shared information about terrain. There's a ford at coordinates Delta 3-2, can support Shermans, allowing units miles away to adjust their routes. They reported enemy movements. Enemy infantry, approximately company strength, moving north from Charlie 8-1, giving commanders at battalion and division level the intelligence needed to understand German intentions and deploy reserves. They called for air support, guided fighter bombers onto targets, assessed bomb damage, and adjusted fires in real time. The German formation, even with superior tanks, couldn't match this coordination. German tanks advancing into American positions often found themselves attacked from unexpected directions, by enemy forces they hadn't known were present, while artillery fell with uncanny accuracy on their assembly areas. German after-action reports repeatedly note surprise, confusion, and the American ability to concentrate forces rapidly at critical points. What seemed like American numerical superiority was often actually superior coordination. American units could bring more force to bear at the decisive point because they knew where the decisive point was, and they could get there faster because they could coordinate movement. Facing Tigers and Panthers. Nothing in this analysis should minimize the genuine terror that German heavy tanks inspired in Allied crews. The Tiger I, with its 88mm gun and heavy armor, could destroy a Sherman from the front at 2,000 yards while remaining nearly invulnerable to the Sherman's 75mm gun at any range. The Panther, introduced in 1943, combined excellent armor with a high-velocity 75mm gun that could penetrate a Sherman's frontal armor at extreme ranges. American and British tankers who faced these vehicles understood, viscerally, that they were outmatched in a direct fight. Sergeant Lafayette Poole, one of the most successful American tank commanders of the war, described encountering a Tiger in France. "We hit it 3 times at about 600 yards. We saw the rounds impact, saw the sparks, and the Tiger didn't even slow down. It turned its turret toward us, and we reversed at full speed into a sunken road. The 88 round went right through the space where we'd been 3 seconds earlier. If we tried to fight it straight up, we'd all be dead." This was the reality of tank versus tank combat when Shermans faced Tigers or Panthers. But the critical point is that Sherman doctrine specifically avoided those fights. American training emphasized that tanks were not primarily tank destroyers. That role belonged to dedicated tank destroyer battalions equipped with vehicles mounting high-velocity guns. Sherman tanks were for exploitation, for supporting infantry, for engaging soft targets and lighter German vehicles. When faced with heavy armor, the doctrine was clear: report, evade, coordinate. That third element, coordinate, was what radios made possible and what German formations couldn't replicate. A Sherman platoon encountering a Tiger wouldn't try to fight it alone. The platoon leader would radio coordinates to the company commander, who would radio battalion, who would task a tank destroyer platoon, M10S or M36S with more powerful guns, to engage. Meanwhile, the Sherman platoon would keep the Tiger under observation, reporting its movements, preventing it from advancing, but never exposing themselves to unnecessary risk. If tank destroyers weren't available, other options existed. Artillery could be called to pin the Tiger in place, preventing it from maneuvering. Air support could be summoned. AP-47 Thunderbolt with rockets could kill a Tiger from above, where its armor was thinner. Infantry with bazooka teams could be guided to flanking positions. The Sherman platoon acted as the coordinator, the eyes and intelligence for a combined arms response that would bring overwhelming force against the German heavy tank. German Tigers and Panthers, despite their power, operated under severe constraints. They were mechanically unreliable. The Tiger's complex overlapping road wheel system meant that in Russian winter conditions, mud would freeze in the wheels overnight, immobilizing the tank until crews chipped it free. They consumed fuel at prodigious rates, making them vulnerable to fuel shortages that plagued German forces especially after 1943. And critically, they couldn't coordinate with supporting elements effectively because they lacked the communication systems to do so. A Tiger platoon encountering American resistance couldn't instantly call for artillery support, couldn't radio for infantry to clear anti-tank positions, couldn't coordinate with adjacent units to develop a flanking attack. They could fight with the weapons they had, from the positions they occupied, based on what they could see. If that was sufficient, if they encountered poorly positioned American units in open terrain, they would win decisively. But increasingly, as American forces learned and adapted, Tigers and Panthers found themselves in situations where their technical superiority couldn't compensate for their isolation. The battles in Normandy's Bocage country illustrated this dynamic perfectly. The hedgerows created compartmented terrain where long-range gunnery was impossible and where coordinated maneuver was essential. German heavy tanks, unable to engage at the ranges where they dominated, unable to coordinate effectively with infantry and supporting weapons, found themselves ambushed, flanked, and destroyed by American forces who used superior coordination to offset inferior equipment. A Sherman couldn't kill a Tiger frontally, but 3 Shermans coordinating their attack, one drawing fire while 2 moved to flanking positions, could disable or destroy the same Tiger with shots to the thinner side and rear armor. What German commanders realized too late. German military professionals were not blind to the coordination problems plaguing their forces. Heinz Guderian, the architect of German armored doctrine and later Inspector General of Panzer troops, wrote in his memoirs about the frustration of watching superior German equipment fail to achieve decisive results. He attributed this partly to Allied air superiority and numerical advantages, but his private papers and post-war interviews reveal he understood the communication gap. In a 1943 memo to Hitler's headquarters, Guderian requested massive increases in radio production, arguing that every tank, every armored vehicle needed transmitting radios. "Our tanks fight as individuals," he wrote, "while the enemy fights as formations. Until this changes, our technical superiority will not yield the victories it should." The request was denied. German industry, struggling to produce enough tanks, aircraft, and ammunition to meet existing demands, couldn't divert resources to a comprehensive radio upgrade. Erwin Rommel, commanding German forces in North Africa and later in France, repeatedly noted in his papers the American ability to concentrate forces rapidly and to adjust to changing battlefield conditions with a speed German forces couldn't match. After the war, when interrogated by Allied intelligence officers, Rommel's former staff officers described his frustration with communication limitations. "The Feldmarschall would develop a plan," one staff officer recalled, "and issue orders to formations. But once those formations moved beyond radio range, or once the situation changed, we had no way to redirect them. The Americans seemed to adapt constantly. We felt we were fighting in slow motion while they operated at double speed." Otto Carius, a German tank ace who survived the war and wrote extensively about his experiences, described the communication problem from a tactical level. "Many times we would encounter American tanks and destroy several, only to find that more appeared from directions we hadn't anticipated. They seemed to know where we were to coordinate their movements, while we had only what we could see from our vision blocks. After the war, when I learned that every American tank had a radio, many things that seemed mysterious became clear. The German military's emphasis on Auftragstaktik, mission-type orders that gave subordinate commanders freedom to use their initiative, was supposed to compensate for communication limitations. Junior officers were trained to understand the commander's intent and to accomplish the mission using whatever means they deemed appropriate. This worked brilliantly when German forces were advancing, when initiative meant exploitation and rapid movement. It worked far less well on the defensive when coordination between multiple units was essential, when information about enemy movements needed to flow quickly up the chain of command, when reserves needed to be committed at exactly the right place and time. By 1944, German commanders were attempting to compensate for communication deficiencies through increasingly detailed pre-battle planning, trying to anticipate every contingency and issue orders to cover all possibilities. This made German operations more rigid, less able to adapt to unexpected Allied actions. American commanders, confident in their ability to adjust plans in real time based on radio communications, could be more flexible, more willing to modify operations based on what their subordinates reported from the front lines. Industrial America and standardization. The radio advantage wasn't accidental. It reflected fundamental differences in American and German approaches to military production. The American industrial system, geared toward mass production and standardization, treated radios the same way it treated engines or transmissions, as essential components that would be installed in every vehicle, produced in massive quantities with interchangeable parts and standardized designs. The SCR-508 radio was manufactured by multiple contractors: Galvin Manufacturing Corporation, later Motorola, RCA, Westinghouse, and others, all building to identical specifications. An SCR-508 built in Chicago was functionally identical to one built in New Jersey, which meant training materials were universal, spare parts were interchangeable, and maintenance procedures were standardized. Tank crews trained on the same radios they'd use in combat. Maintenance crews stockpiled spare parts that would work in any SCR-508. This standardization extended beyond hardware to doctrine and training. American tank schools taught radio procedures as basic skills, as fundamental as driving or gunnery. Every officer and NCO going through armor training learned to coordinate platoon movements over radio nets, to call artillery fires, to report intelligence up the chain of command. The FM manuals, field manuals that defined American military doctrine, assumed radio communications in every chapter on tactics. The production numbers tell the story. By the end of 1943, American industry was producing approximately 50,000 military radios per month. Germany, at peak production, was producing about 8,000 per month, and many of those were for aircraft, ships, and other non-tank applications. The Germans simply couldn't equip their armored forces with comprehensive radio communications even if they'd wanted to. They didn't have the industrial capacity. American factories were also producing the less visible but equally essential supporting infrastructure: spare parts, test equipment, training manuals, maintenance guides. A Sherman battalion deploying to Europe carried not just radios but complete sets of spare components, crystals for different frequencies, testing equipment to diagnose problems, and trained radio maintenance specialists. When a radio failed, it could often be repaired in the field within hours. When it couldn't be repaired, replacement radios were available from supply depots. German units, by contrast, often waited weeks for replacement radios, operating in the meantime with degraded communications. Spare parts were scarce, and with multiple different radio models in use across different tank types, maintaining an adequate parts inventory was nearly impossible. The German system, for all its tactical and operational sophistication, was brittle, dependent on fragile equipment that couldn't be easily replaced or repaired. This industrial reality shaped the war. American armored divisions could sustain high operational tempos because their communications infrastructure remained intact. German formations, even when they received new tanks to replace losses, often received them without radios or with radios incompatible with existing frequencies. The German order of battle might show impressive tank strength on paper, but the actual combat effectiveness was degraded by the inability to coordinate those tanks in battle. The network beats the weapon. Zoom out from individual tank battles and the larger pattern becomes clear. American success in armored warfare wasn't about building better tanks. It was about building better systems. The Sherman was a component in that system, optimized for its role. Reliable, easy to maintain, adequately armed for most targets it would face, and equipped to communicate with everything around it. At the platoon level, 5 Shermans with radios fought as a coordinated unit, not as 5 individual tanks. The platoon leader orchestrated movement, concentration of fire, mutual support. At company level, the commander could mass fires from 15 tanks on a single target, or divide his company to engage multiple targets simultaneously, all while maintaining coordination. At battalion level, the commander had real-time information from 50 or more armored vehicles, allowing him to understand the battle as it developed and to commit reserves where they'd be most effective. But the system extended beyond tanks. American doctrine emphasized combined arms, tanks working with infantry, with artillery, with air support, with engineers, with tank destroyers. Making combined arms work required communication, and that's where American forces excelled. A Sherman company encountering a German defensive line wouldn't just fight with tanks. It would coordinate with attached infantry to clear anti-tank positions, with artillery to suppress enemy forces, with engineers to breach obstacles, with air support to strike German reserves. The radio networks made this coordination possible. Forward air controllers, often riding in specially equipped Sherman tanks, could talk directly to fighter-bomber pilots overhead, directing them onto targets that ground forces had identified. Artillery forward observers could receive target coordinates from any tank in the formation and could fire missions within minutes. Infantry battalion commanders could coordinate with tank battalion commanders to develop joint assault plans, with both sides contributing to a shared understanding of the battlefield. German formations, built around the idea of the tank as the decisive weapon, struggled to achieve the same level of combined arms integration. Their tanks were powerful, but they fought in relative isolation from their supporting elements. When German armor attacked, their supporting artillery often couldn't adjust fires quickly enough to keep pace with advancing tanks because communication between armor and artillery was limited. German infantry, advancing to consolidate gains made by tanks, often found themselves cut off from their armored support because coordination broke down once units moved beyond visual range. This systemic advantage compounded over time. American units that suffered losses could be reconstituted quickly, with replacement crews integrating smoothly because they trained on the same equipment and doctrine. German units, suffering comparable losses, received replacement crews who often hadn't trained together, who might be operating unfamiliar tank models, who couldn't immediately integrate into whatever ad hoc communication networks their units had developed. The American system was robust. The German system was fragile. The quiet advantage. The Sherman tank's legacy has been argued over by historians, veterans, and military analysts for 80 years. Was it a death trap that sent American crews to their graves? Was it a war winner that overwhelmed German forces through sheer numbers? The truth resists such simple characterizations because the Sherman was never meant to win the war alone. It was meant to be part of a system, and understanding that system requires looking beyond armor thickness and gun calibers to the less dramatic but more decisive question of how military forces coordinate, communicate, and adapt. In the final accounting, Germany built tanks that were superior in protection and firepower to anything the Allies fielded until the very end of the war. The Tiger, the Panther, even the late-model Panzer IVs had advantages in direct combat that cost Allied crews their lives. But those individual advantages couldn't overcome systemic disadvantages. German tanks fought the war they were designed for, the war of the armored duel, the breakthrough, the decisive engagement. American tanks fought the war they were designed for, the war of coordination, adaptation, and combined arms. The radios that hummed in every Sherman turret, the crystal-controlled FM sets that allowed clear communication across miles of battlefield, the training that taught American crews to fight as networks rather than as individuals. These were the quiet advantages that won armored battles from Tunisia to the Elbe. They didn't make dramatic headlines. They didn't inspire the kind of fear that a Tiger's 88mm gun inspired. But they worked consistently and decisively in ways that German commanders recognized too late and couldn't counter with the resources available to them. When the war ended and military analysts studied the lessons of armored warfare, they didn't conclude that thicker armor or bigger guns were the path to victory. They concluded that coordination, communication, and combined arms were decisive. Every modern tank, whether American, Russian, German, or Chinese, carries sophisticated radio systems because the lesson of World War II was clear. A networked force of adequate weapons defeats an uncoordinated force of superior weapons. The Sherman proved that truth on battlefields across 2 continents, not through the thickness of its armor or the power of its gun, but through the quiet, constant chatter of radio communications that turned individual tanks into elements of a larger, more capable, more adaptable organism. Germany built the better tank. America built the better system. And systems, not weapons, win wars.